Hey everybody, Mr. Wada here, and today we're going to be going over something called bond number. So, if you take a look at this as a 3-day cycle, the first day we went over how to make Bohr diagrams and showing where all the electrons and the atoms are by shell or by level, that'd be the rings. The second day we did Lewis diagrams. We were focusing on just the valence electrons and where those would go, how many each one should get. And then today we're going to be focusing on what those Lewis diagrams can tell us about the number of bonds an atom will make. If we take a look at the first example up here, we've got fluorine. We're going to do aluminum, beryllium, sulfur, and sodium afterwards. And what you're going to notice is that we're using the same two sets of elements alternating so that I can give you answers to part of it, and you can also get good practice. Bond number equals the number of bonds an atom can make. That makes pretty good sense, number of bonds equals bond number. It also equals the number of unpaired electrons in the Lewis diagram for the atom. So we're going to go in order across the list here, starting with fluorine. So fluorine is element number 9. It's in group 7A, or 17. Since it's in group 7A, it has 7 valence electrons. So that means that for our picture, we're going to draw 7 electrons around this fluorine. And remember, the way that we add these electrons is important. So the order that I do this in is the same order you need to do this in, because otherwise you're not going to get the right bond number a lot of the time. All right, so for this one, it would work regardless of how you do it, but fluorine has 7, so you're going to go 1, 2, 3, 4, 5, 6, 7. If you look at that, you'll notice that there are 3 pairs of electrons. You have a pair here, a pair here, and a pair here. There's one lone electron. And since bond number equals the number of unpaired electrons in this diagram, that means it has a bond number of 1. Okay, so why does that matter? That means that this one electron right here can bond to something else. So I'm going to show that this electron can attach to a free electron on a different atom. So another one that would work like this, hydrogen. Hydrogen is in group 1, right here. So it has 1 electron. If you bond that electron with the one in fluorine that's free, you make what's called hydrofluoric acid. So each free electron can bond with another element by sharing these electrons between these two atoms. So each free electron then is worth 1 bond, which is why bond number equals the number of unpaired electrons. So if we do the same thing for aluminum now, aluminum is element 13. It's in group 3A. That means it has 3 free electrons. Now, again, I said it's important how you add these, because if you don't do this right, you'll end up with 2 at the top and 1 on the right. That would be incorrect. You're going to go top, right, bottom. And since we've drawn it this way, those 3 valence electrons, you can see are each unpaired, so that means a bond number of 3. Since there's a bond number of 3, that tells you it can make 3 bonds. Each one of these electrons could bond with something else. If you had done this just by counting like 1, 2, 3, you would have had 2 at the top here and 1 on the right, and it would have told you it could only make 1 bond. Notice the difference there. Next up is beryllium. Beryllium is element number 4, and it's in group 2. Means it has 2 valence electrons. 1, 2. Those 2 valence electrons are both unpaired, so that means it can make 2 bonds. So you could add one thing here, one thing here. You can kind of treat these lone electrons sort of like those circles on a Lego block, where each circle is a place where you could put another Lego onto it. You could also look at this as like bungee cords or a rope or something attaching 2 things together. The point is that each one of these is a spot where you could attach something else to it. All right, next up is sulfur. Sulfur is in group 6. It is element 16. Since it's in group 6, it has 1, 2, 3, 4, 5, 6 valence electrons. And then the question is, what's its bond number? So you have 2 pairs of electrons here, 1 pair here and 1 pair here. there are 2 unpaired electrons, 1, 2. So that means its bond number is 2. This may seem weird at first, but beryllium and sulfur can both make the same number of bonds, even though they're in very different spots on the table. But what you may notice is both of those are 2 spaces away from the noble gases at the end here. I'm going to add one more. I forgot that it's supposed to be here. What was it? Oh, it was argon. Sorry. Forgot to put this one on there. I had notes because I wanted to end with this. All right. I don't know how clearly you can see that now, but I'll slide the paper over a little. Okay, so the second to last one is sodium. Sodium is Na. It is in group 1. It's element number 11. Since it's in group 1, it has 1 valence electron. You can put that 1 valence electron anywhere because there's nothing else to compare it to. It doesn't matter. It would just be the same as rotating this. Same thing. So since it has 1 valence electron, that means it has a bond number of 1. Sodium can make 1 bond. Something that you've probably seen in the past, or heard about at least, is table salt. Sodium chloride. Notice how chlorine has 7 and sodium has 1. They're both free ones here. Sodium and chlorine bond in a slightly different way than the examples we've done so far, but the fact that there is 1 space here for chlorine and sodium has that 1 electron explains how you would get that number. What you'll notice is that once you go through this, there's a very set pattern to the numbers you're going to get for all these. For example, 8 is the max that you're going to get for the examples that we usually do. All right, last one here is argon. And argon is element 18, and it's in group 8A, so it has 8 valence electrons. I'm going to shift this over just a little bit to make sure you can see it. So it's going to have 8 valence electrons, 1, 2, 3, 4, 5, 6, 7, 8. By the way, the reason I did those in order, just counting 1, 2, 3, 4, 5, 6, 7, 8, instead of going in that pattern where you go top right, bottom left, is because I knew that it already has 8. And it doesn't matter how you add them because 8 will pan out the same regardless. So if you look at that, there are 4 pairs of electrons. There are none that are unpaired. So this means it has a bond number of 0. Argon and all the noble gases have a bond number of 0, which is why they don't bond with other things, which is why they're called the noble gases. They are noble or stay by themselves. Really old, like, tossing shade over there. The nobles were made fun of in chemistry. But anyways, there's no free electrons, so there's no way for those to bond. Okay, so those are the examples I'm going to do. What I'm going to ask you to do is to then take a look at these examples down here, and your assignment for the day is to try and do this process for these 5 elements here. So you've got lithium, silicon, oxygen, chlorine, and neon. Again, if you have any questions, let me know either through email or on Google Classroom. Have a good rest of your day.